Hi all, here are your notes for 9.5, the Pythagorean Theorem. Wow, this is something you probably haven't done for a while, but it applies to our squares and square roots. So we tackle it right now again, and hopefully this is mostly a review for you. But if it's not, hopefully it's not too hard. The Pythagorean Theorem is what we use for right triangles. And I'll draw you or show you right triangle and draw you some to remind you of what that is, but it relates the leg and the hypotenuse. So let's go through some words to remind you how to do some of this stuff, okay? First of all, the Pythagorean Theorem, it has to do with right triangles and only right triangles, so it has to have a right angle on one of the corners, okay? It has to be a right triangle. The sum of the squares of the legs, oops, there's a typo there, A and B, let me fix that, it should be an S, equals the square of the hypotenuse. So if you remember, A squared plus B squared equals C squared from somewhere in your past, good. The legs are always A and B. Now it doesn't matter which one's A and which one's B, but they are always the two attached to the right angle. The hypotenuse is the longest side, and it's always the one across from the right angle, not either one of the legs. The triangle might be spun around and not this direction, and you have to know which ones are A, B, and C. And again, A and B don't actually really matter which one you choose to be A and which one you choose to be B, but C does matter. It's the hypotenuse, it's the longest side of the triangle, and it's across from the right angle. Now, our equation is A squared plus B squared equals C squared. So if I add the square of A, the square of B, I always get the square of C. And I like this picture to show you this. So if I have A is 4, because that's 4 units long, and B is 3 units long, then C is 5 units long. This is why this works. So if we square 4, we get 16. Hence, there's 16 squares here. And if I square 3, I get 9. 16 plus 9 is 25, just like it says here in our equation. And so the square of A plus the square of B always equals the square root of C. So let's do, an example problem, or let's put it up here again. So if I have A squared plus B squared equals C squared, I'm just going to always fill in what I know. Let's say we know A and B. So the picture told me A was 4 squared, and the picture told me B was 3 squared is supposed to be equal C squared. Well, let's solve this. 16 plus 9 is C squared. 25 is C squared. This is like your lesson yesterday to solve this. I'd take the square root, they would cancel, and C is 5, and it was 5 units long. Let me just mention the bottom down here too. Here's another equation chart for you too. That will, if you need to solve for C, A, or B, you can use these. So they're there for your reference. And then a Pythagorean triple is any set of numbers that'll be the correct sides, the leg, and the hypotenuse for a triangle, a right triangle. And for example, 3, 4, 5 is called the Pythagorean triple. It's the one we just used above in the notes. You got a list in your notes, so make sure you look at that, and we'll use this in a minute in our notes. All right, so first of all, let's start with some notes, and I'm curious what side I have a question mark on for you, so just keep in mind. So I have A squared plus B squared equals C squared. A is a leg, B is a leg, C is the hypotenuse, hypotenuse, okay, the longest side. A and B are shorter, C is always the longest side. So on this first triangle right here, this is a leg, this side where my question mark is, because it's attached to the right angle. So this is either A, B, C, or this could be B, A, C. But note, I always put C on the hypotenuse, the angled side. Okay, it doesn't actually matter which one's A and which one's B. All right, this triangle now, the second triangle. What leg or hypotenuse do I have marked? Well, This is a leg because it's attached to the right triangle, and this is a leg because it's attached to the right angle. So this is AB or BA. It doesn't matter. I can flip those two, but this is C that I have marked on this one. All right, over on my last triangle, I've got a leg here and a leg here. So this is either A, B, C, or B, A, C. Notice how C still stayed on the slanted side. You have to know what variable you're solving for today, or you'll get your answers wrong. So we got to know what we're solving for today. All right, so let's do our first problem. We are always going to write our equation and then fill it in. All right, first I need to know what side is that. Well, that's a leg and that's a leg because they're attached to right angles, so this is C. So I'm solving for C right now. I don't know C. So let's say 9 is A and 12 is B. It doesn't really matter, but let's fill them in. So I'd have 9 squared, because that's my A, plus 12 squared, because that's my B, and my question mark is C. I don't know it, so I write C squared. That's what I'm solving for. I'm going to solve for C. So let's fill this in. I have 81 plus 144 is C squared. Let's finish solving. So I have 81 plus 144 is 225 is C squared. Now I'm going to take the square root to cancel it. And 225 is a perfect square. Hopefully you're starting to learn those. It's 15. So C is 15. Now a really good check is C always has to be the biggest number. Always. And 9 and 12 and 15, that'll work. Okay? That is actually a Pythagorean triple then. 9, 12, 15, those are 3 sides of a possible right triangle. All right, number 2. I'm going to write my equation. A squared, B squared, C squared. Oh, I forgot my question mark. Let's put it in. It should be right here. All right, what am I solving for? I'm solving for one of the legs. Okay, so we'll call 14A. I don't know B. And 50 is C. You have to know which one, because if you put it in for B, 50 in for B, you're going to get the wrong answer. So we got to put it in for C. So let's fill in what we know. We knew 14 squared. I'm solving for B. You could switch 14 squared in for B squared, and you could have A squared. You still get the same answer, okay? Because they're on the same side of the equation. They can add in any order. That is the commutative property of addition. And it equals 50 squared. You're going to definitely want a calculator as your friend here, but I'll give you some numbers. 196 is 14 squared. I do not know B squared. And 50 squared is 2,500. Solve the equation. Minus 196, I got to move it over. B squared is 2304. Now, off the top of your head, you probably do not know this, but that is a perfect square. So you're going to want to use your calculator, and you're going to take a square root now, and on your calculator, you're going to do square root of 2304, and you're going to get an actual number for it. It's 48. So 48 times 48 is 2304. Now, a good check is to think about it. 48. So I had one of my legs 14, 148, and my longest leg's 50. That's reasonable because 48 is less than 50. Number 3. What am I solving for? I have a leg, and I'm solving for another leg, and I have a hypotenuse already. So this will be C, this will be A. Let's say we're just solving for B again. Again, it doesn't matter if I solve for A or B. It's going to give me the same answer. So I have A squared, B squared, C squared. All right. Let's fill in what we know. A is going to be 36 squared. That's going to be a big number. I'm going to solve for B squared. And that's going to give me C squared. Ooh, 85 squared. That, again, will be another large number. All right, I'll give you the answers, but you're going to need to use your calculator, obviously. 36 squared is 1296. I do not know B squared. 85 squared is 7,225. Solve the equation. Minus 1296. Gone. B squared is 5929. All right, I'm going to check on my calculator. Is that a perfect square? And actually, it is. It's 77. So let's think if that's reasonable. 36, 77, 85 should be my longest side. Proportionally, the way I drew this, 77 is longer than 36. So that looks good. My B side is 77. All right, finally, these are our Pythagorean triple. And I say it like a question because is this? Okay, so I want to know, could these be the measures of a right triangle? Could a triangle be, and that's not to scale, people, not to scale, 11, 60, 61. How did I know to put 61 on the hypotenuse? Because it's the biggest number, and that's the longest side. So how do I figure this out? Well, I use my equation. A squared, B squared, C squared. This will be A, this will be B, and this will be C. You could flip the A and the B, it doesn't matter, but 61 has to be C because it's the biggest number and it's the hypotenuse. So let's check it. Is 11 squared plus 60 squared 61 squared? Is it? I don't know. Let's solve for it. 11 squared is 121. 60 squared is 3600. 61 squared is 3721. 3600 plus 121 is 3721. So my answer is, and I don't know where I write it, I'll write it over here. Yes, it is a Pythagorean triple. We can even put an exclamation behind it. Let's check a couple more. Is this a Pythagorean triple? Okay, I skipped one, I did. It's at the bottom, down here. Is this, let's do this one first, a Pythagorean triple? Okay, 9 is my biggest number, so that's going to be my C. We'll just put them in order then. So is, let's actually write it, A squared, B squared, C squared. Is 5.4 squared, and you can do that on a calculator, plus 7.2 squared, 9 squared. Well, I don't know, let's figure it out. All right, on a calculator, I'd be doing 5.4 squared. You are going to get 29.16. 7.2 squared on a calculator is 51.84. 51.84, 51 and 84 hundredths. Does that equal 81? Let's do the math over here. 29.16 plus 51.84. Let's math it up. 10, carry the 1. 10, carry the 1. Drop the decimal. 11, carry the 1. 81 equals 81. So yes, it is a Pythagorean. It's a possibility that we could have a triangle be 5.4, 7.2, and 9. That does work. That says 5.4 down there. And again, not to scale, not to scale. All right, let's do another one. Number 6, is this a Pythagorean triple? Well, I don't know. Let's figure it out. All right, here's the deal. If I don't know which number is biggest, what you might want to do on your calculator is plug in 5 square root of 17. And you're going to get a decimal answer. And if I take this on my calculator, I get 20.6155. It's irrational, so it's going to go on forever. That is, the only reason I'm doing that is just to make sure that's C. That's the biggest side, okay? These could be out of order, so you might want to check that 5s, don't be deceived because there's a 5 out front. That is actually the biggest number. So this is going to be my A, my B, and my C. Okay, so I have A squared, B squared, C squared. So I have 13 squared plus 16 squared. Does that equal 5 square root of 17? I'm going to put that in parentheses. Squared. Try to square the whole number. Out. Let's figure it out. 13 squared is 169. 16 squared is 256. All right, I got to figure out how to square over here. So let's write it down. So this squared applies to both things in here. So 5 squared is going to be one portion of it, and then square root of 17. Maybe I'll put parentheses around them, square. All right, so what does that do? Well, 5 squared is 25, and then I'm multiplying between these two, so times. And then just remember, a squared cancels a square root. So this is going to be 17. I got to figure out what 25 times 17 is. Well, that's 425. All right, so does that equal 425? Let's do a little math. 169, 256 plus 15, carry the 1, 12, carry the 1, 4. Ooh, 425 equals 425, yes. Now, I gave you all yeses in here to show you that a lot of these are Pythagorean triples, but not everything is actually going to be a yes. Sometimes in your homework, you're going to get a no. No, it's not. It doesn't equal. And that's okay too. It just means those can't be the side lengths for a right triangle. All right, good luck with your homework, everyone. Miss you all. Hopefully I get to see you very soon. Have a great day.